In this video, we're going to learn about the empirical and molecular formulas and how to determine the empirical and molecular formulas for a compound or a molecule. The molecular formula for a compound or molecule is the formula which specifies the actual number of atoms of each element. So if you take a look at this picture here, there are two different substances, one on your left and one on the right. If you take a look at the one on the left, how many carbons do we have? We have 4 carbons. How about hydrogens? Count them. We have 10 hydrogens. So we say that the molecular formula for the substance on our left is C4H10. We are literally counting the number of atoms of each element. What about the substance on the right? How many carbons do you have? How many hydrogens do you have? And how many oxygens do you have? C2H4O2 is the molecular formula for that substance. And I know what you're thinking. How do you place them in order? Well, most of the times, the problem will actually tell you the order of the elements. Now, the empirical formula is the formula with the smallest whole number mole ratio of the elements. So, if you take a look at the substance on the left, we say that there are 4 carbons and 10 hydrogens. The ratio of the elements is 4:10. Well, can that be reduced? Yes, it can. So the empirical formula is C2H5. The 4:10 ratio is reduced to 2:5. What about the substance on the right? The molecular formula is C2H4O2. Well, what is the empirical formula? CH2O. Now determine the empirical formula of these molecular formulas. So again, all you're going to do is reduce the ratio. So for example, H2O2, the ratio is 2:2. Well, that can be simplified to 1:1. And so the empirical formula is HO. Go ahead and complete this list. Play the video when you're done. Did you get the following answers? Let's talk about C2O3 real quick. For that one, the empirical formula is the same as the molecular formula because the ratio 2:3 is already simplified. So sometimes the empirical formula will be the same exact formula as the molecular formula. Sometimes you will be asked to determine the molecular formula given the empirical formula. To do that, we're going to find N, which is the molar mass of the molecular formula divided by the molar mass of the empirical formula. And then we will distribute N to the given empirical formula. So let's take a look at the first example. Determine the molecular formula for the compound C2H3O2 that has a molar mass of 118.1 grams per mole. The first thing we want to do is find the molar mass of C2H3O2. So go ahead and determine the molar mass of C2H3O2. The molar mass is 59.05 grams per mole. And then the second step is to determine N. N is the molar mass of the molecular formula divided by the molar mass of the empirical. So in this case, we will put 118.1 on top divided by 59.05. And that is equal to 2. So with that 2, we're going to distribute to every single element from our empirical formula. And so when you distribute, remember you're multiplying, our molecular formula is C4H6O4. Now when you are asked to find the molecular formula and you are solving for N, you will always be dealing with a whole number. Sometimes when you divide, you might get a value of 1.999 or 2.001. But that's close enough to round to the whole number, and so whenever you see that, just remember to round it to the whole number.